to explain you a Leetcode problem. The problem is maximum sum subarray. So it is one of the problem in Leetcode. So the maximum sum subarray. The problem statement is given an array say the array name is ARR with n elements. Given an array ARR of n elements, our objective is to find the subarray of maximum sum. So our objective is to find the subarray of maximum sum. Okay. So before that, we need to know what is a subarray. So this is an array. So the array index starts from 0. So in this array, I can able to store 7 elements. For example, take the elements of the array as so in this array we are going to find the subarray. So there are different possible combinations of subarrays available. 2 is a subarray, 2 minus 3 is a subarray, 2 minus 3 6 is a subarray. There are different combinations available. Minus 3 6 is a subarray, minus 3 itself is a subarray, 6 8 is a subarray, minus 1 7 minus 3 is a subarray. There are different combinations of subarray available. The subarray should be continuous. We should not take like the subarray should not be like 2 minus 3 minus 1 7 like that. So the subarray should be continuous. So these are all the different possible combinations of subarray, and we are going to find the sum of each subarray. And after that, among all these sum, we need to calculate the maximum sum. So we have to compare all these sum and we need to find the maximum sum. Sum of this subarray is 2. Sum of this subarray, the subarray elements are 2 and minus 3, the sum is minus 1. The sum of this subarray is 5. The sum of this subarray is 9. 3 plus 6, 9. Likewise, we need to compute the sum, and then finally we need to find the maximum sum among all the computed sum. So this is about subarray. So our aim is to find the maximum sum subarray. Okay. And how will you find this maximum sum subarray? There are two approaches. I am going to explain you the approach number 1 first. So the approach number 1 is we can iterate over all these subarray combinations. Okay, I already mentioned you different combinations of subarray. So we need to iterate among all possible combinations of subarray to find the maximum sum. Okay. So how we can implement it as a code? So I am going to write the routine or the function of this maximum sum subarray. I am not going to write the entire program. I am going to write only the maximum sum subarray function. Okay. Here the function name is max sum subarray of, from the main function, the argument passed are the array and the number of elements. So here in the function definition it accepts the array and also the number of elements n. This is the function to compute maximum sum subarray. Okay. So we need to declare the sum as 0, and also we need to find the maximum sum which is equal to nouns of 0. Okay. it is a straightforward or naive approach, or we can say it is a brute force approach of solving a problem. So it is a simple brute force approach of solving a problem. So we are going to iterate all these subarrays to find the maximum sum. So for that we need a loop to iterate. So for int I is equal to 0, so the array index starts from 0 and it should go up to the length n, and then every time it should get incremented. And inside that, okay, I just declare the sum, and here the sum is 0, and then I am going to use the another loop. Int j is equal to 0, j equal to I. So the next loop should start from I equal to 0, and next loop should start from I. So j should start from I, j less than n, j plus plus. So here n is the number of elements. Okay. So here we need to compute the sum. Sum is equal to sum plus ARR. ARR is the array name, ARR of G. If the sum is greater than the maximum sum, initially we assigned the nums of 0 as maximum sum. If the sum is greater than the maximum sum, then what we have to do is, so now the sum is greater than the maximum sum. Always the maximum sum should be greater. So we need to assign the sum to maximum sum. So now the sum is the maximum sum. Sum value is assigned to maximum sum. Okay, I'll continue here. If sum is greater than maximum sum, the maximum sum is sum. Okay. So finally we need to return. So what we need to return is, so after this we need to return the maximum sum. Okay. So here we are using two loops. So it should iterate among all subarrays to compute the sum and maximum sum. Okay. For example, take an array 2, 3, -5, 8. In this subarray, the maximum sum will be provided by this subarray 8. This subarray 8, because this is -5. Okay. So in this, using this algorithm, using this program, so here this is I and the j, here it is. Okay, this is the subarray length now. So I to j is the subarray length. So I is 0, I starts from 0 and j starts from I. Okay. So this 2 is the subarray, and compute the sum. Now the sum is sum plus array of j. Okay, the initial sum, it was 0. So sum is equal to sum 0 plus array of j. Array of j is 2. So the current sum, which is 2, and the maximum sum is, it was assigned as nums of 0. That is also 2. So maximum sum is again 2. Okay. So now compare these two. If sum is greater than maximum sum, then sum should be assigned to maximum sum. But here it is equal. It is not greater than. So leave the maximum sum as it is. So the maximum sum is 2. Okay. Now the iteration of inner loop will iterate again, and j should be less than n. So now the j is incremented. It moves to 1, the first index. It was in the 0th index before, and now j is incremented and it moves to the first index. And 1 is less than the total number of elements 4. Yes, it is true. And sum is equal to sum plus array of j. The previous sum, it was 2. So sum is equal to sum, the previous sum 2 plus array of j. Now the j, it is here. Array of j is 3. So what is 2 plus 3? It is 5. Now the current sum is 5. Okay. Now compare the current sum with the maximum sum. Sum is 5. So we need to compare the current sum 5 with the maximum sum, the previous maximum, which is 2. This is greater. So if it is greater, change the maximum sum is 5. Now the maximum sum, which is equal to 5. So this is the maximum sum now. Okay. And so for the next iteration, so j should be 2. J gets incremented, it is 2. Okay. So now compute the sum. The sum is sum of all the elements. The sum is 5 minus 5, which is 0, but the maximum sum still remains the same, that is maximum sum is 5. Because sum is lesser than the maximum sum, so this condition gets false, and the sum now it is 0 and maximum sum still remains the same. Now j gets incremented, j is 3. So from 2 to 8, the total sum, that is 5 minus 5, 0 plus 8, 8. So the sum is 8 and the maximum sum 5 or 8. Now 8 is greater than maximum sum. So the maximum sum now it is 8. The sum is 8 and maximum sum is 8. Okay. So this is for one iteration. So this is for inner loop. Again, what will happen? The score is less than 4, condition false. So this gets false and I gets incremented. So it is 1. I gets incremented from 0 to 1. 0 plus 1, it is 1. So now for the second iteration. Okay, now the I value it is here. Okay, this 2 is left out from this array. So we are going to consider only this ith position to jth position. Okay, so now I is in the first index and the value of I which is pointing is 3. Okay, so now j is again pointing to I, so that is our length of the subarray is 3. For this the sum is 3 and maximum sum is again 3. So the maximum sum it was 8, the previous it was 8. Okay, compare with the sum and maximum sum remains same. Okay, next j gets incremented. 3 minus 5, it is minus 2. The sum is minus 2. The maximum sum remains same. And then j gets incremented. Now compute, add the sum from 3 to 8. 3 minus 5 plus 8, which is 6. So the sum is 6, sum will be 6. And the maximum sum remains same, that is 8. Okay, and then, so this inner loop gets completed. So next I gets incremented. This is I and here this is j. So for this subarray of minus 5, so the sum is minus 5, but the maximum sum remains same. And j gets incremented again. Minus 5 plus 8 it is 3. Compare this sum with maximum sum. Sum is lesser than maximum sum, so the maximum sum remains same. So after that j gets incremented, 4 less than 4 condition false, and then I gets incremented. Now I is in 2. Now 2 plus 1 it is 3. So 3 less than n, condition 2. 3 less than 4. So now I gets incremented and j it is again points to I. So now we are considering only the subarray element of 8. Okay. The sum is equal to sum plus array of j. 8. It is 0 plus 8 and then maximum sum, which is the previous maximum sum it was 8 and now the maximum sum, now compare with this sum, maximum sum and the sum. 8 is equal to 8, so there is no change. The maximum sum still it is 8. So this is the final answer. So after that, j gets incremented, 3 less than, then 4 less than 4 condition false, and then I gets incremented 4 less than 4 condition false. So the total the iteration is over, and finally we get the answer of maximum sum, and finally it is returned as maximum sum here. Okay, this is the simple function to compute maximum sum subarray, and this is a brute force technique or naive approach of solving a maximum sum subarray problem. And there is another approach of solving the same problem, and we need to compute the time complexity here. The time complexity of this algorithm is, the main function is computing sum and maximum sum and comparing with each other. And for that, we need to consider the loops, the inner loop as well as the outer loop. The inner loop executes for n times. Inner loop executes for n times, and outer loop executes for another n times. So it is nested loop. So the execution of inner loop takes n times, and execution of outer loop takes another n times. So the time complexity, it will be n into n, which is n square. Okay, the time complexity, it is n into n, which is n square. So the total time complexity of this algorithm is big O of n square. Okay, so the first approach, the time complexity of the algorithm is big O of n square. Okay, so this is the first approach. Now we are going to see the second approach of solving the same problem. So consider this array. So instead of doing the process of n square, here in the second approach we are going to solve the same problem using big O of n. So the time complexity we are going to solve is big O of n. So how we are going to solve this problem is by using an algorithm which is called as Kadane. So Kadane algorithm. So using this Kadane algorithm, we are going to solve this maximum sum subarray problem with the time complexity of big O of n. So we are going to solve this with the time complexity of big O of n. So the Kadane algorithm, what it is instead of doing two loops, instead of nested loops, we are going to use only one loop. And if the array is negative, if array or sum is negative, if we find the sum as negative value, any negative value, then we are going to omit it. So that is the main thing in Kadane algorithm. So the important thing we have to note here is the sum should not be negative. If the sum is negative, we are going to omit that. Okay, we are going to make the sum as 0. Okay, how we are going to omit that negative value? We make the sum as 0, we can omit it. Okay, so this is the main objective of Kadane algorithm. So take this subarray. Okay, so now compute the use the Kadane algorithm. Okay, so now compute the sum. Sum is 0. Sum is initialized to 0. Okay. So now I is here. Compute the sum. Sum is equal to sum plus array of I. The sum is 2. So 2 plus the previous sum value, it was assigned as 0. So initialized to 0, and the maximum sum, it is initialized as nums of 0 or array of 0. Okay. So the array name ARR of 0. So sum is 0 and maximum sum is array of 0. So consider this array name is ARR. Okay. So sum is 0, 0 plus the current value, which is 2. 0 plus 2, it is 2. And what is maximum sum? Initial maximum sum is array of 0. Array of 0 is again 2. So compare these two, the maximum sum is again 2. Okay. There is no change here. And increment the I value. Okay. Now, what is the current I value? It is 3. The previous sum, it is 2. So now the I value is here. It is pointing to the array of 1, that is 3. So the sum of this subarray is 2 plus 3, which is 5, and compute the maximum sum. The previous maximum sum, it was 2, and now the sum is 5. Compare these two. This is the maximum, so change this as the maximum value. So the maximum sum is the current sum. Okay. Now increment the I value. So I value now it is minus 5. The previous sum, it is 5. Okay. So minus 5, for example, take this is 6, minus 6. Okay. For understanding, so take this is minus 6. Okay. So the previous sum, it is 5. So 5 and the current value, it is minus 6. So 5 minus 6, which is minus 1. This is a negative value. Whenever in the Kadane's algorithm we see the negative value, we need to make the sum as 0. So we are going to make this sum as 0 here. So 5 minus 6 is equal to minus 1. We are going to make this as 0. Okay. So now the current maximum sum. So maximum sum still is the same. Still it is 5. And then I gets incremented. The previous sum, it is 0 plus the current value it is pointing, the array of I is pointing to third position, that is the value in it is 8. So 0 plus 8, which is 8. Okay. And the maximum sum, it was 5, and compare these two values, this is greater, so change this as the maximum sum. So now the maximum sum, it will be 8. Compare these two, this is greater, so make this sum as maximum sum. So the final answer is 8. So the result is this array will give the maximum sum. This is the subarray which gives the maximum sum. Okay. So here in Kadane's algorithm, the idea is to omit the negative sum. Here we got the negative value, so we omit that subarray, entire subarray. So this doesn't result in a maximum sum subarray. So that's why we omitted this. This is applicable for all subarray of any length. And the final sum subarray we got is 8. So which subarray results in 8, the maximum sum? Simply 8. 8 is the subarray which results in maximum sum for this array. Okay, this is by using Kadane's algorithm. So this is the main idea of Kadane's algorithm. And I am going to implement that as a code. So in maximum sum subarray, this is the function name, and I am going to pass the array as an argument, and n is the number of elements. So I am simply writing the sub function, that is to compute the maximum sum subarray, not the entire program. So in this we need to declare what is sum and also the maximum sum. So the maximum sum, it is, ARR. Here the array name is ARR of 0. The previously I wrote that as nums, I think. So change that as ARR of 0 in the first approach as well. So in sum is equal to 0, maximum is array of 0, and then we are going to use only one for loop for this. Only we used only one pointer, which is I. In the previous approach we used two pointers I and j. That's why our time complexity increased to n square. Okay, here we use only one pointer, that is I int I equal to 0, I less than the number of elements, I plus plus. And then compute the sum value. Sum is equal to sum plus array of I. If sum is greater than the maximum sum, then assign the current sum value to the maximum sum. And then in Kadane's algorithm we need to compare another one thing, which is the sum should not be negative. So for that we are going to compare the sum with sum should always greater than 0. If it is not greater than 0, for example, if it is less than 0, what we need to do is we need to make the sum as 0, because that subarray will not lead to the maximum sum. So this is the important part in Kadane's algorithm. So if sum is less than 0, sum should be 0. Okay. So here we need two comparisons. One is like the previous approach, sum should be greater than maximum sum, and the second comparison is in Kadane's algorithm, the sum should not be negative, so we make the sum as 0. And after that, finally, we need to return the max. Okay. We are going to return the maximum sum. So this is the output. Okay. Here this loop will execute for n times. Here this loop is going to execute for n times. So the time complexity of this algorithm is big O of n. Okay. So this I starts from 0 and ends with 3. So it should go from 0 to 3. That is, it should traverse from 0 to 3. That is, it should go to all the elements. Okay, it should reach all the elements to compute the maximum sum. So the time complexity of this algorithm is big O of n. So compare these two time complexities. Approach 1, which uses a simple brute force approach, and approach 2, it uses Kadane's algorithm. So when we are using Kadane's algorithm, big O of n, and when we are using brute force approach, it is big O of n square. So how we are going to compare these two time complexities? So how we can say this time complexity is better than that? Okay. So for that, we need to consider the order of growth. Okay. So we need to know what is order of growth. Okay. For example, if n is the number of element is 5. Okay. What is n square? The time complexity will be n square for the first approach. N square is 25. It takes 25 milliseconds to compute. It takes a time of 25. And if the n is 5, and for this approach n is 5, so it is twice the order of growth of n. So the order of growth of n is comparatively twice, order of growth of n square is comparatively twice than that of n. N is 1, if If n is 1, then the n square is also 1. If n is 2, the n square is 4. If n is 3, the n square is 9. If n is 4, the n square is 16. If n is 5, the n square is 25. So the order of growth is increased like this. Okay, the n is like this and n square it is like this. So the order of growth is much higher for n square when compared to n. So this is n square. So the order of growth of n square is very bigger compared to n. So that's why we are saying this is better than this n square. So this we got from the Kadane's algorithm. So finally, for computing maximum sum subarray, the better algorithm you can go for Kadane's algorithm. That will use the time complexity of big O of n. And I hope you all you can understand what this Kadane's algorithm is and how we can compare the two time complexities to find the efficiency of an algorithm. Thank you.